In this video, we're going to talk about exponent properties. And before we get started, I want to note I'm going to be using the letters A, B, and C to represent unique numbers. And this is to generalize the exponent properties for any numbers that you could possibly be working with. So let's look at the first property, which says that if you have a number A raised to some power B, and you're multiplying that again by a number A, same number, raised to the power C, you simply can add the exponents and condense that into a single a raised to some exponent. Why can you do that? Well, a to the b power means a times a times a b times. It just means multiply a, b number of times. And similarly, if you have a to the c power, it's the same thing. Note, we are multiplying when you do exponents. It's just a shorthand for multiplication. But then if you again multiply that by the same number, well, note you'll be just doing multiplication all the way across for the whole entire thing. So let's use a real example to try to figure out how we get this property where we simply just add these exponents. Well, what if we had a to the third power be multiplied by a to the second power? The property says that that should just be a to the 3 plus 2, which should be a to the fifth. Well, let's see. A to the third power means what? It means a times a times a. Now don't forget to multiply here because we're multiplying. So it's a times a times a times a to the second power. That's a times a. Well, look what we have. We have all multiplication. A times a times a times a times a. That's just a 5 times being multiplied. So it is a to the fifth. So it looks like our little property works for this case. And I can assure you it doesn't work for only this case. It works for any case, for any numbers you pick for B and C. It'll always work. Note that it only works, though, this property only works when you have the same number for the base. So if you had some number, A, and a different number, B, raised as some exponents, and they would be multiplied, you couldn't use this property. And I encourage you to test that out and see why. And I'll give you a little hint. PEMDAS, the order of operations, is what dictates why you cannot do that. Now, if you actually knew what A and whatever your bases were, you can go ahead and carry out everything, but you can't simplify and use this property. So let's look at another property, which says if you have A to the B power, I guess I don't need those parentheses. Let me get rid of that. A to some power B, that's a B there, not a 6. Raised to some power a divided by a raised to some power c. Well, we can simply write that as a to the b minus c. Whatever your exponent in the numerator is minus the exponent in the denominator. So again, why does that work? Why do we have this property? Well, let's look at a real case. What if you had a to the 5th power and we divide that by the same base, a, right, to the 2nd power? Well, our rule says this should simply be a to the 5 minus 2, which happens to be a to the 3rd power. Well, I can assure you that is true, and I'll even prove it to you. A to the 5th power, let me move up here just so we can see that. A to the 5th power, well, that's a times a times a times a times a. And then we are dividing by a to the 2nd power, a times a. Well, this is all multiplication on top and bottom here. This is a fraction. We know from arithmetic rules that when you have fractions and you're multiplying, you can cross-cancel numbers that are in the numerators with numbers in the denominator if they're the same number or if they share common factors. In this case, we have the same numbers. We have a and a, right? So we can cancel one of these a's up top with one of these a's on the bottom. And we cancel another one of these a's with this other a on the bottom. And then we just are left with a times a times a in the numerator. And in the denominator, we do have a 1 here. We don't usually write it. It's implied. So we simply have a cubed over 1. I'm just going to leave that as a cubed because we don't need to write the over 1. Note that this is the same thing. It's a cubed. We get the same answer that's predicted by our exponent property. And I assure you this works for any exponents that you could have chosen. This always works. Even when the the number on top, the exponent on top, is less than the number on the bottom, you will get a negative exponent, which will go into what that means, but it always works. Let's look at another one. What if we have the number a raised to the b power, and then that entire thing is raised to the c power? Well, the exponent property says that this is a to the b times c. It says multiply your exponents. Well, let's prove again why this property works. Well, let's choose some real numbers for b and c here, just to show one example. What if we had a squared and that whole thing was raised to the third power? Well, this outer exponent, this 3 here, this is saying, look, whatever's in this parentheses, I want you to multiply it by itself 3 times. I don't care if it's a single number a, if it's raised to an exponent, if there are 2 numbers being added, multiplied, whatever. So let's just simply write whatever's in the parentheses be multiplied by itself 3 times. So it's a squared times a squared times a squared. Well, we can expand out everything in these parentheses, because a squared, we can write that as a times a, right? That's what a squared is, or a to the second power. And we can do that for all 3 of these here. And so this is all multiplication. Parentheses mean multiplication. When you have something in parentheses and you have some other parentheses in front of it or some other number in front of it, that means multiplication. So we have a times a here times, for this parentheses, a times a. And again times a times a. So you have a times a times a times a times a times a. 6 a's being multiplied together. Well, that's simply a to the 6th power. And that's what we should have predicted using our rules. We had a 2 and a 3 for our exponents, and this says multiplying them together will give us the answer. So 2 times 3 is 6. Note that when we expand that out, that's exactly what we get. We get a to the 6th power. And so this works. Now, if you memorize these exponent properties, which I'm not a big fan of memorizing in math, but some of these properties are helpful to memorize. It's just a few of them. But it's good to know how they work. And if you understand how this works and you do 1 or 2 examples yourself to prove it, that's probably good enough. But note that no matter which way you do it, use the rule, or if you actually expand it out and look at it, you always get the right answer. You get the same answer. So let's look at one more property. So if you have a times b in parentheses, and that entire thing is raised to the c power, the property says you just do a to the c times b to the c. It's saying, look, put the exponent on both numbers here. So again, why does that work? Well, what if you had a times b raised to the 2nd power? Well, this says whatever's in the parentheses, multiply that by itself twice. So note here, we have ab, which means a times b, times ab. Well, we can drop the parentheses and just say, I'm going to write this as a times b times a times b. And then this might not be totally apparent as to why that is related to that up there. But if we use the commutative property of multiplication, we can group the a's together and group the b's together. And if you don't know what the commutative property of multiplication is, it simply says, look, the order in which you multiply things, if it's all multiplication, the order in which you multiply, it doesn't matter. You're always going to get the right product. It doesn't matter the order in which you multiply. It doesn't matter how many numbers you have being multiplied. It doesn't matter what way you choose to jumble them up. You will always get the right product. So we could take advantage of that and say, why don't we group together numbers that in such a way that it helps us make sense of things. So why don't I put the a's together, a times a, and then those are being multiplied by b times b. And that literally is the same thing as what I have up top. If you don't believe me, try some real numbers. Try 3 times 2 times 4, try 2 times 4 times 3, 3 times 4 times 2. Jumble those up whatever way you like. Do as many numbers as you like. You'll notice you'll always get the right answer, the same answer at the end. And so we do this because it helps us. Because now, in the form we've written it, we see that we have a times a. Well, hey, that's just a squared. Times b, well, that's just b squared. Well, look, this just showed that we got the answer that was predicted by this property. It says if you had two numbers being multiplied, and really this is any number of numbers being multiplied. I just used 2, but if it was A times B times C times D, in the parentheses, same thing. You always just put the exponent on all of them. If you do that, then you'll get the right answer. As if you'll get the same answer as if you were to expand everything out, group everything together, and go through all that process. But if you remember this rule, you don't have to go through all that. You'll just know how to do it. You'll get the right answer, which is a vital skill once you move on to higher math when you have more involved problems. And so I'm going to do another video that goes over a few more exponent properties. I'll see you then. Thanks.